Hi everyone, it's Miss Cronky here to introduce our next topic that we'll cover in our e-learning adventure. It would come to us from chapter 7 and it's all about rational expressions. So this week we're going to focus on the different types of operations that we can do with things that are rational expressions. So in the word rational, there is a math word, okay, and that math word is the word ratio. And we've talked about ratios before, and you might recall that they are things that look like fractions. So when we're working in our assignments this week, you're going to see things that look like fractions. They have numerators and denominators. Okay, so I'm going to say the numerator and the denominator of a rational expression are polynomials, and that was a whole chapter that we covered in first semester, polynomials. So you can have monomials, which mono means one, binomials means two, trinomials, and you can even have higher than that. So those like monomial, binomial, trinomial, those are referring to the number of terms in the polynomial, the things that are being added or subtracted. So I'm going to call them, in my rational expression, I'm going to call it like a p of x. So there's some polynomial in the numerator that we could call p of x. And then there's a q of x, okay, in the denominator. So that's another polynomial, whatever that might look like, however many terms it has. Okay. And then note that q of x, because it's in the denominator, cannot equal 0. Okay, so this is important for you to know later on when you start graphing rational expressions, that anytime the denominator is equal to 0, you don't have an output for your rational expression. So this results in a restriction to your domain. And you're going to see me talk about that here in some of our examples that we have to be careful of. Most of the time you don't always like list the restriction to the domain. Everybody just knows it's a fraction and the bottom of the fraction can't be 0. But we are going to, in some of our operations, going to have to be specific about some things that won't work. And we'll talk about that here briefly. Okay, so in this video, we're gonna do 3 different operations. We're gonna simplify, we're going to multiply, and we're going to divide. And then in the next video, you're going to add and subtract. Okay. So simplify rational expressions. Okay. Basically here, there's 2 steps to simplifying rational expressions. Step 1, factor everything. Okay. Step 2, cancel out common factors in the numerator and the denominator. So you're really sort of like reducing a fraction like you would normally, like 6 over 8. That has a common factor of 2, 2 times 3 over 2 times 4, and then you can cancel out the 2's, okay? So this first example that I have is actually an example from Algebra 1. So you've already done problems like this before. And my 2 expressions in the numerator and the denominator, they're not polynomials, but rather monomials. So they have one term, okay? So on this one, I don't really need to factor. I can just go through and sort of simplify one part at a time. So you can look at the 2 over 8 first. Okay. If I'm looking at 2 over 8, I recognize that both of those have a factor of 2, so I can reduce each of them, dividing by 2. So that's really going to be a 1/4. Okay, so I'll have 1 in the numerator and 4 in my denominator. And then I'm going to look at my x's. So I have x squared over x, and remember that means in the denominator here this is x to the first, and by properties of exponents, if I have the same base and I'm dividing 2 powers, I can subtract the exponents. I always ask myself this question, where are there more x's? So x squared is bigger than x to the first. That there's more x's in the numerator, so when I do my subtraction, I'm going to leave it in the numerator, and then 2 minus 1 is 1, so there's an x to the first, or x in the numerator. And then I can go and I can do the y's. So now I'm looking at y over y to the 4th. They have the same base. And similarly, this y has an exponent of 1. Now when I ask myself the question, where are there more y's? Y to the 4th is actually bigger than y to the 1st. So y is going to, I just leave it in the denominator. That way I can avoid a negative exponent and do my subtraction down there. So it'll be 4 minus 1, which is 3. It's okay if you do like y to the 1st and then subtract 4, then you would get y to the negative 3 in the numerator, and of course you would flip that down into the denominator. So at the end of this, you should always have only positive exponents in your simplified form. If you have a negative exponent after doing some kind of subtraction, go ahead and flip that to the opposite location, numerator or denominator. Okay. Now, what I really want is for these two expressions to be equal to each other. But something I have to be thoughtful of right here is if I think about this first expression and I focus down here on the denominator, 8xy to the 4th, and I think about that rule that the denominator cannot be equal to 0. Okay. Well, there are a couple of ways that the denominator could equal 0. What if x was 0? Then 8 times 0 times y to the 4th, no matter what y is, the denominator would equal 0. And also, what if y was 0? Then 8 times x times 0 to the 4th would be 0. Okay, so in this expression, this first one, before I simplified, x cannot be 0 and y cannot be 0 because they make the denominator equal to 0. Now notice in my answer over here, x over 4y cubed, anybody who looks at this would know y can't equal 0. If y is 0, then you're dividing by 0, and that's not a real answer. So we know that the domain is restricted for y equals 0, and that matches what was true over here. But because we did that subtraction with the x's, we don't know in this answer that x cannot be 0. So we have to make an extra statement such that x does not equal 0. So any factors that you may have canceled from the denominator that once restricted the domain need to be listed after the simplified form so that these two things are actually equal. Because if I made a table of values for the expression on the left and someone else made a table of values for the expression on the right, they would get an answer when x is 0 when there shouldn't be one. Okay, so you have to tell people x cannot equal 0. Okay, that's like algebra 1. Now we're going to get into some algebra 2 stuff. So we want to just simplify this expression, x squared plus 5x plus 6 and x cubed plus 2x squared. These are not monomials anymore. In your numerator, you have a trinomial because you have 1, 2, 3 terms, and in your denominator, you have a binomial, 1 term, 2 terms. Okay. You want to be really careful here. You cannot cancel terms. You can only cancel factors. So remember to simplify, step 1 is factor everything that's possible. So basically, you look at this in 2 different ways. Check your numerator. Can you factor x squared plus 5x plus 6? Would be x plus 2x plus 3. Maybe double check by refoiling to make sure you factored that correctly. And then in the denominator, can you factor x cubed plus 2x squared? Well, this one's not a trinomial, but it has 2 terms. And what I notice about both terms is they both have x squared in them. So we can take out the greatest common factor of x squared. And when we factor that out, we're left with an x plus 2. Okay, so I've completed step 1, which is factor everything. Okay. Now I'm going to do step 2, cancel any common factors in the numerator and the denominator. Maybe there are common factors, maybe there aren't. In this case, there are. I can cancel out the x plus 2. I don't have any other common factors. So then my final answer is just going to be x plus 3 in the numerator divided by x squared. I can't reduce these x's because they're not factors. This x up in the numerator is a term. Okay. And then I want to look at my denominator. Okay. And I want to focus on anything that I canceled from the denominator, which was this x plus 2 term. Because that was a factor of the original, that meant if I set that equal to 0, x equals -2 would make this whole denominator equal 0. Think about -2 cubed is -8. -2 squared is positive. 4 times 2 is positive 8. So -8 plus 8 would have been 0, and that would be undefined. But we've crossed it off right here, so nobody knows that x cannot equal 2. So we have to say such that x does not equal, sorry, -2. If I said +2 before, I apologize. We don't have to list the restriction that says x does not equal 0. That is true. X can't equal 0 over here because 0 cubed plus 2 times 0 squared is 0. But x can also not equal 0 here. Everybody sees that. So we don't have to list the restriction to the domain that is true for both. We just have to list the restriction to the domain that we canceled out. And then one other one really quickly, just to review some factoring, x squared minus 81, be on the lookout for factorings like this. This is a difference of perfect squares. So that factors to be x plus 9, x minus 9. In your denominator, 2x minus 18. That's another greatest common factor. They both have a factor of 2. Oops. Both have a factor of 2. So then I'm left with 2 times x minus 9. I can cancel the x minus 9s. Okay, nothing else will cancel. So my simplified form is x plus 9 over 2. And because I canceled x minus 9, if you set x minus 9 equal to 0, then you would add 9 to both sides. So 9 makes the denominator equal 0. We want to say such that x does not equal 9. Now, if someone were just like happened upon your simplified form, x plus 9 over 2, this one is interesting because there's not a variable in the denominator in the simplified form. So they would think that this would work for all x's. Like I can always divide by 2. So my domain would be all real numbers. But because it's really the simplified form of this, we know that x cannot be 9 because if we put 9 in here, then we would get 0 in the denominator. So we have to say this, x cannot equal 9, so that x plus 9 over 2 is the same expression as x squared minus 81 over 2x minus 18. Okay, moving right along, we're going to talk about multiplying rational expressions. So just take a quick second here to look over my directions for multiplying rational expressions. It's exactly the same as simplifying rational expressions. So step 1, factor everything. Step 2, cancel common factors in the numerator and denominator. And then basically like write what's left over. Okay, leave stuff in the numerator, denominator, wherever it is. And we'll still do that whole thing where we write out any restrictions to the domain that we canceled out. Before I do one where we have to actually factor, I'm going to do a review of Algebra 1. So we have 3x over 5x squared times x z cubed over 18y squared. There are a couple of different ways that you could have approached this in Algebra 1. Like if you wanted to, you could multiply across on top in the numerator, multiply across on top, or multiply across in the denominator, and then do all the simplifying. But when you're multiplying fractions, you can also do cross-canceling. So if you have a common factor in the numerator and in the denominator on either fraction, you can reduce. So like I see that I have 3 over 18. Well, those are both divisible by 3, so that would be a 1 and a 6. Okay. If I wanted to, I could say like this x in the numerator will cancel out the square so that there will only be an x left over in the denominator. But then this other x in the numerator will cancel out the other x that remains. So now all the x's are gone. I don't really see anything else that is going to cancel. So now I'm just going to like multiply across on the top. So everything that's left over on the numerator, which is only a z cubed. And then everything that's left over in the denominator, so that will be 5 times 6, which is 30, and then a y squared. And again, if you wanted to multiply across at the very beginning, that would be fine, and then you would just be reducing with smaller or with larger numbers. Okay. Of course, check your denominator. Okay, so did you cancel anything that could make the denominator equal 0? Yeah, we canceled this x squared. Okay, it canceled out completely with the 2 x's that were in the numerator. So we don't know that when x is not equal to 0, that is a restriction to the domain. We don't even see x there, but we'll list that x not equal to 0. Okay, now to the ones that are more like algebra 2, where you actually have to do some factoring. So really important to make your life easier, we're not actually going to multiply these polynomials. That would be kind of a lot of work to do all the distribution and combining of like terms. So what you want to do is start by factoring everything. So I'm going to factor the numerator of the first fraction, x squared minus 2x. They both have a factor of x, so I can take out the GCF. Can I factor the denominator, x squared plus 2x plus 1? Yes, that will be x plus 1 times x plus 1, or you could write that as x plus 1 squared. Okay, move on to the second fraction, x squared plus 4x plus 3. That's going to factor to be x plus 3, x plus 1. And then in the denominator, x squared plus 3x, they both share a common factor of x. Take that out of both, so then we're left with x plus 3. So I factored everything, I've completed step 1, and now I'm going to go through and I'm going to check, do I have any common factors in a denominator and a numerator? So one factor has to be in the top, one factor has to be in the bottom, they have to be exactly the same. Well, I'm noticing x plus 3. I can cancel one of my x plus 1s, and then I can cancel that x, that greatest common factor of x. So now I have nothing left to cancel. I just write whatever is left over. So that's going to be x minus 2 over x plus 1. This is a simplified form after I multiply. And then I also have to say all the things that x cannot be that I canceled out of the denominator. So go back and look at any of the factors that you canceled in the denominator. You don't really have to worry about the numerator, although there are going to be some of the similar ones because you canceled in both, but you're really focused on the denominator because you can't divide by 0. So that would be -1, 0, and -3. Okay, those are the restricted values. Okay. All right, I'll do one more multiply and then we have a division problem. You know, sometimes these can look overwhelming with all the polynomials that you have, but you just have to take one part at a time and work on the factoring. So factoring 2x cubed minus 12x squared, that has 2 terms. They both have a factor of 2 and they both have a factor of x squared, so I can take that out of both. I'm left with x minus 6 in the numerator. And in the denominator, x squared minus 4x minus 12, that's going to factor out to be x minus 6x plus 2 times, and then x squared plus 9x plus 18. Let's see, factors of 18 that add to 9, that's going to be x plus 6, x plus 3. Make sure you're factoring correctly, choosing the correct factors, signs and everything. And then in the denominator there, 8x squared plus 24x, they both have a factor of 8. They both have an x in them, so I can take that out of both. I'm left with x plus 3. Go ahead and do your canceling of any common factors. Notice that they can be in the same fractions, or you can cancel like I'm going to do for the x's right here, x squared in a numerator and x in a denominator. So I'm going to cross off the square. I'm going to cross off the whole x right there. They don't have to be in the same fraction. Just one has to be in the numerator, one has to be in the denominator. And then I can also reduce the 2 over 8 because that divides by 2 to get me 1, and this will get me 4. It looks like I've canceled everything. Be careful on this one. Remember that an x remained in the numerator, and then there was an x plus 6. So when I write my answer, I'll have x times x plus 6 all over, and then we have the x plus 2 and the 4 that are left over. You don't have to like multiply this stuff out. You can just leave it in the factored form. That's the way it will be on the key if you're checking the key. And then go through and list off any x's that you know are not going to work in the original. So we crossed off the x minus 6, that would be a positive 6. We crossed off the x, which would be 0, and we crossed off the x plus 3, which would be a negative 3. So those are the things that x cannot be. Okay. All right. And this is really great practice for review of factoring. And if you have lots of questions about factoring, try to come to one of our office hours or email us with your questions. Okay, but that's a really important skill for you for next year. Okay, last one real quick is divide rational expressions. So if you kind of look over my instructions for dividing rational expressions, you're going to see there is one change. When you're dividing fractions, you're really multiplying by the reciprocal. But then everything else is the same. Factor everything, cancel common factors in the numerator and the denominator. So for this last example that I have here, I would kind of make note that I have division right here. Okay, so remember that you're going to multiply by the reciprocal right here. So when I do my work, I'm going to factor the first fraction like normal. That's going to be x plus 7 and x minus 5. And then in the denominator, I'll have x minus 3 and x minus 4. And then instead of writing divide, I'm going to do a times. And what I'm going to do is I'm going to flip it now. So the denominator was 3x squared minus 12x. I can take out a 3, I can take out an x, and I'm left with x minus 4. So that's now my numerator. Okay, so I'm flipping it over here. And then I'm going to look at the numerator, x squared minus 13x plus 40. So that's going to be an x minus 5 and an x minus 8. So I said, I'm going to multiply by the reciprocal. Here's me multiplying by the reciprocal. I flipped it. Okay. And now I can start cross-canceling things in the numerator and things in the denominator. Looks like that's about it. Write what's left over. That's going to be a 3x times x plus 7. That's going to be an x minus 3 times x minus 8, such that x does not equal. We crossed off the x minus 4. We crossed off the x minus 5. So that's going to be positive 4 and positive 5 for our answer. Okay. So what we did here is we simplified rational expressions. We multiplied and divided rational expressions. Basically, you're always, if they look like polynomials with more than one term, you're going to try to factor everything and then cancel the common factors in the numerator and denominator. Don't forget to write any restrictions to the domain that you may have crossed off. And in the next video, you're going to be adding and subtracting rational expressions. Okay, have fun. Email, visit us at Zoom if you have questions. It's been fun.